Okay. Question number 6 is asking for a square root, right? We're told the square root is approximately this. So I know that the square root of 81 is a 9 and the square root of 100 is 10. The number we're looking for, right, is right between those. So it's got to be between 81 and 100. And so K has got to be our answer. Number 7, our first probability question. So we had to find a probability that is not grape flavored. 2 ways to do it. Find the probability of everything that is not grape, right? Like there's 4 lemons and 3 strawberries and 1 cherry, right? So when I add those up, that's 8 out of 10, which is 4/5. The other way is to do 1 minus the probability of grape, and grape is 2 out of 10, right? So do 1 minus 2/10 gives me 8/10. Cool. So that's number 7. 8 is asking for where the endpoint will be. Now this one I kind of do differently than some formulas out there. Like we're told point B is -3, 4. So there's point B, right? It's at -3, 4. I've just plotted out, and they gave us graph paper for this question, so I'm going to do it that way. And it tells the midpoint is 1, 2. Here's the midpoint, 1, 2. So they're asking where would the other point be to make this a midpoint? Well, what I would do is it looks like we're going down 2 and over 1, 2 over 4. So it looks like to go from B to the midpoint is down 2 and over 4. So I'll do the same thing. Down 2 and over 4, which is at the point 1, 2, 3, 4, 5, 0, which is letter K. That's the quickest way I know to get there. There are other ways which are more complicated, but I think just thinking about slope is probably the quickest way to get there. Question number 9. We've got to write out a formula, right? They have 116 customers, which is 8 more than, so 8 plus, twice the number of customers they had a year ago. So 2 times X. I solve this out and I get 54. The question's asking how many customers did they have a year ago? Well, yeah, that is it, 54. Number 10 talks about a fence, right? It's a 200-foot long fence. They charge a $500 set fee, right? Plus a set amount per foot of fence. I'm not sure what that amount is, but they have 200 feet of fence times that set amount per fence. And we know that the estimate is $2,200. So I know that this amount's got to equal 2200. I solve for X, I get 850. Okay, question 11, our first quadratic type question, right? So if you're in college algebra right now, I believe you already multiplied quadratics a while back, and I think the same with algebra 2. One way to multiply these out, there's that FOIL method, right? There is another way where you can take these pieces and put them in the outside of a box, right? 3x plus 6, 3x plus 6, and 2x minus 1. And then to get these black numbers, I just multiply, right? 3x times 2x is 6x squared. Same thing with all the others. And then just add up the black numbers. They give us 6x squared plus 9x minus 6. Again, you could also get it by doing the FOIL technique. And if you do the FOIL technique, 3x times 2x is 6x squared. That would safely eliminate A and B automatically, right? And then you got to kind of carry out the rest of the way on it. Okay, so that is 11. Let's look at 12. 12 is one of those questions. ACT usually has 2 of these where they've got a stem for you to read, and then they ask questions later on based on the stem, right? So what I generally do is when I see these, I go right to the question because I'm going to have to go back anyway to figure out the information. And it says Jeremy's got $10 in quarters. What's the maximum number of quarters he would have left after paying for a box of 25 candies? Well, if I look, 25 candies at Tamika's treat shop, 25 candies would be $4.25, right? So if I took the $10 and subtracted the $4.25, that would give me $5.75. Well, how many quarters is that? Well, $5 is 20 quarters, so 75 cents is the 3 remaining quarters, right? So 23 quarters total. 13 says at Tamika's Treat Shop, what's the average price per candy in a box of 20? Well, if I look at, here's Tamika's, right? Here's Tamika's. In a box of 20, the price is $3.75. So I'm going to take that $3.75 and just divide by the 20 pieces. And I get 0.1875, which in terms of money is 19 cents, right? Letter B. Number 14, which of the following gives a relationship between the price in dollars, C, and the number of candies, N, in a box? Well, I copied down the information there from Carrie's Chocolate Shop, right? 0 candies was, I didn't know what it was, but for 5 candies was $1.50, 10 candies was $2.50, 15 candies was $3.50. I'm looking at it, and this side here is increasing by 5 each time, right? The right side is increasing by $1 each time. So slope would be $1 divided by 5, which is 0.2. That's our slope. And of our choices, the only choice that has a 0.2 for a slope is letter F. Okay, 15. Mr. Chang made the true statement. At least one student in this class is a section leader of the band. Which of the following statements must be false? And again, has to be false. He says at least one student is a section leader. So the false statement would be no student is a section leader, because Mr. Chang says at least one person is the section leader. Well, that must mean letter E is false, because letter E says no student is a section leader. All right, now let's look at 16 here. Again, 16, remember, things are drawn to scale. So if I'm trying to figure out what this angle is here, 90 degrees would be this much. This is definitely more than 90. So I can safely eliminate choice F just outright. Now, I do know that if this is 140, well, then this has to be 40 because they make a straight line. If that's 148, this has to be 32 because, again, they make 180 a straight line. Trying to figure out that angle. Well, we know in a triangle, all 3 angles together must add up to be 180. So if I took 180 and subtracted to 40 and subtracted to 32, we would have 108. Okay. 17 talks about notepads, right? And we're told that the box is, let's see, it measures 9 by 9 by 12. So 9 by 9 by 12. That's the box we're looking at. And I generally try to, if they give me something, I try to draw a picture for myself. I know I like seeing a picture. It makes it easier to do. Plus, by drawing the picture, it kind of helps me enter the problem a little bit. Now we're told each notepad is in the shape of a cube, right? So it must be one of those like Post-it notepads. And the edges are 3, right? Each side is a 3. So I thought about this and I went, well, if it's 9 across and each of those is 3, wouldn't there be like 3 notepads across, right? 3, 6, 9, same thing here. And then going up, if each is a 3, 3, 6, 9, 12, there'd be 4 notepads going up. Well, how many notepads are there here? Well, 3 across, 3 deep, and 4 tall. 3 times 3 times 4, 36, letter E. 18 is function notation. They're asking for what is f of -4. So I take my problem and change the x's to be -4. And I would recommend you typing this into your calculator complete with the parenthesis signs, because you're bound to make an error somewhere there. Like this part, -4 to the 3rd power is -64. Some people might say +64, be careful. Other people might try multiplying this first and then doing the 3rd power. If you're going to use your calculator, just type it in exactly the way it appears. We get letter J, 192. Number 19 says, which of the following is a solution to that system of equations? So I kind of wrote out the 2 system equations in black here. And let's see, I decided to eliminate the x's. So I multiplied the top equation by a 2. And that way, when I add them up, these x's cancel, and we're left with 5y equals 15, which means y is equal to 3. Now, what's nice about this, I'm not going to solve the rest of it. look at the answers. Only one of these choices has a y value of 3. Circle letter A and move on. If you have time at the end of the test, come back to this one and make sure that the x is in fact -2. But that's a good way to kind of save some time. And then the last one, number 20, we're going to get into Pythagorean theorem either tomorrow or the next day. But the question asks for which of the following is the closest perimeter to this. Perimeter means adding up all the sides around it, right? So I could think about 10 plus 8 is 18, plus a 19 is 37. So the perimeter must be more than 37. Now, this is drawn to scale, right? So I kind of know that like this side here is definitely smaller than 19, right? So if I thought about 37 and 19, that would give me 56. And so I could safely eliminate these choices because they're just way, way, way too big. What I did do was, to figure out this missing side, I did something called the Pythagorean theorem, right? A squared plus B squared equals C squared. And we're going to talk about this in a day or two. But all you have to remember is C squared, the C, that's the part that's opposite the right angle. So X, I call that X, that has to be the C. Now 8 and 9, they could be A or B, it doesn't matter. I do the math here, I get these numbers, I add them up, I get 145. To get rid of the second power, we square root both sides and get the square root of 145. So that missing side is the square root of 145. I use my calculator and I wind up with 49.046. Okay, I want to talk about, Mr. Williams is going to come on, I think at 8:20. So we got about 3 more minutes here. I want to talk about number 22, okay? 22 deals with something called similar triangles. We're trying to figure out how far it is from B to C. And we're told some sides are parallel and so on. What it means is this tiny triangle is just a very, very small version of this larger triangle. So I have a hard time figuring out what side goes where. So what I generally do is I redraw this tiny triangle to the side in the same orientation as the large one. Now I know B has got to be here. E, well, that's the part at the end, right? So E has got to be up top here, and then A has to be here. And then I kind of copy down the numbers where they go. And then once it's there, we're just setting up a proportion, right? Like 4 here, the number 4 corresponds to the 12. So I'm going to say 4 over 12 equals what? Well, I'm trying to get to the question mark, 3 over x. That's one way to go about it. Another way to go about it is to notice that 4 times 3 is 12, right? I'm multiplying by 3 to go to the big triangle. So if I multiply this by 3, I would get the big triangle, which is also 9. Okay. Let's see here. Okay, if you all could go to number 48, all right, and this will probably be the last one before Mr. Williams kind of takes over here. There's generally maybe one question dealing with matrices on the ACT, okay? So this question asks, which of the following matrix products is undefined? So they'll ask you either to add them, subtract them, multiplying, whatever. All a matrix is a box with a bunch of numbers. I kind of imagine like this matrix X. That's 4 people sitting at a table for lunch, maintaining their social distance, right? And each number is what that person is. So kind of think about that idea. Now, if I'm going to multiply matrices, what you have to do is make sure that the number of people sitting this way is equal to the number of people sitting this way. Because what you would do is you'd multiply those corresponding pieces. That's how matrix multiplication works. So if I look at XZ, for example, I wrote down matrix X here, and then I wrote down, so this is matrix X, this is matrix Z. When I go to multiply them, which is this, I'm going to take these numbers and multiply these by these. So it'll be like 3 times 5 plus 9 times 2 plus, see how there's nothing for the 3 to multiply by? That's why that's trouble. There's no way to multiply those. All right, Mr. Williams, are you there?
Yeah.